Hi, Chemistry 12-2. Welcome back. It's week 8, and this is our second video. We're going to take a look at how to name or draw structural diagrams for the remainder families in hydrocarbons, or under our hydrocarbon title. And we're going to take a look at alkenes, alkynes, cyclic hydrocarbons, and aromatics, a special case of cyclic hydrocarbons. But before we jump right in, I wanted to do a couple things. First, I need to remind you the importance of practice here. The practice is key, and so you actually, it's a little different this week. You have 3 worksheets under files in week 8, and those worksheets are really, really important to take a look at before you start your assignment. So much so that I'm not going to post the assignment until maybe Wednesday of this week. And each of the worksheets have the answer keys attached, but it's key to try the worksheets first, at least 4 or 5 problems before you check the answer key. You need to build your confidence, you need to make mistakes, and you need to practice naming hydrocarbons. The rules that you see here on the slide are really the rules we use to name any organic compound we're going to tackle this week and next. So it's really key to be okay with these steps, how they work inside and out, and we use hydrocarbons to practice with these steps, and I really need you guys to do your practicing. So worksheets, 1 is on alkanes, naming and drawing, 1 is on alkenes, naming and drawing, alkynes, so the alkenes and alkynes are together on a worksheet, and the 3rd worksheet's on cyclic or cyclo hydrocarbons and aromatics. Okay, so do the practice, then move to the assignment. The assignment's not that long, and so the practice is what's key here. Just before we jump into alkenes, I wanted to, because these steps are so important, I wanted to review very quickly the naming of alkanes and the drawing of alkanes, and then we'll carry these steps forward, or these rules forward, and name the rest of the families we want to talk about under the heading of hydrocarbons. You'll remember hydrocarbons have hydrogens and carbons. Carbons are special. They have 4 covalent bonds. Thanks to their 4 valence electrons, hydrogens have 1 covalent bond, and so they combine to make hydrocarbons. So if you take a look at these steps, this is a review from our last video. Number 1, find the longest chain of carbons in your molecule. Number 2, number the carbons in the main chain in sequence. Remember, we can number from left to right or right to left. How do we make that decision? If we have branches, we want to give our branches the smallest combination of numbers possible. Number 3, add numbers to the names of the branches to help keep track of their position. So when we look at a branch, we have to do 2 things. We have to name it, and that's done by indicating how many carbons are in the branch, and we also have to indicate where it is. So what number of the parent chain, what number carbon does that branch attach to. Use prefixes to indicate the same groups that appear more than once. So if we have 2 methyl branches or 3 methyl branches, we tack on a prefix di or tri. Tetra would be for 4. List the names of alkyl substitutes. So when you look here, substituents I should say, alkyl are the YL. That's where our branches, the ending for branches, come into play. And use the proper punctuation. So we want to think about commas and hyphens. So we put commas between numbers when we're doing a name, because it's really a run-on name, and we put hyphens between numbers and letters. Okay, so we want to remember these rules as we go. All of our families with hydrocarbons follow these rules. Really, when we introduce a new family, we kind of introduce one new thing. So these are the basic rules, and every family has kind of one extra thing with their families. Okay, so just to warm up, if you take a look at number 3 down here, it says name the compound using IUPAC names. So we're using our IUPAC names. So the first rule we need to do is find the longest parent chain. So we can turn corners, right? So, but we can't have branches on branches, so be careful with that. So here it looks like a branch, but it's technically, it could be our first carbon. So 1, 2, 3, 4, 5, 6, all right? Or we could go 1, 2, 3, 4, 5, 6. Okay, so there's a few different combinations. How about this? 1, 2, 3, 4, 5, 6. So we get to choose the way we want to count. This sometimes is tricky. People think it's a branch, but if it's a terminal carbon, so you won't have a branch on your terminal carbon. It'll be part of the parent chain if it's there. Remember, terminal carbons are carbons on the left end or the right end of your chain. So here we see, and sometimes I like to circle it just as I'm, come on now, give me a pencil, come on now. There we go. You can circle. Now I like to stay linear, right? So we could circle that way, and that would be your parent chain. But what's nice about it is we're going to get exactly the same answer if we use that as our parent chain. So there's a bit of flexibility here, and you'll see this is going to be an ethyl branch. If we had to put that as our carbon, down here would have been an ethyl branch, but it's still off the third carbon, so it's going to be named the same way when we look at that. Okay, so think about that. This is the trickiest thing when we first start, is finding that parent chain, and they can turn corners. This is what the practice is all about. So let's say we number it. So we say this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Right? So we get to number in the order. So we can number this way. Our branch would be off of the 4. But what I want you guys to also start practicing with is, what if I number it in the opposite direction? And I'm just going to use different color here. Right? So I number it in the opposite direction. My chain is on the 3. So when I number with the red, my branch is on the 4. When I number with the green, my branch is on the 3. We need to number to give, we need to number, gosh, these guys. Oh, I'm off to a good start, aren't I? Here we go, boom. So you can see here we have 1, 2, 3, 4, 5, 6. What's the prefix for 6? The prefix for 6 is going to be, and we need to memorize those prefixes. There are only 10, and only 4 of them are new. So memorize those prefixes. 6 means hex, okay? We use A and E. Do you remember why? There's single bonds, one shared pair of electrons between the carbons, okay? We have a branch. The branch comes first. There's only one branch. It's got 2 carbons in it, so it's an ethyl, right? Prefix for 2, YL for a branch. But we also have to indicate where it is. So we decided to count this way, 1, 2, 3. So it's 3 ethyl. See, I have a number and a letter, so I put a hyphen between them. Boom, it's done. Quickly over here, when we count, you'll see for B, 1, 2, 3, 4, straight across, or 1, 2, 3, 4. You can choose either of those parent chains, because when it's straight across, this is off of the second carbon. If you turn a corner, this is off of the second carbon. We do have to count this way because we want to give our branch the smallest number. So we're going to count 1, 2, oops, got a little carried away there with my 2. 2, 3, 4, you get the idea. And my branch is 1 carbon. So 4, the prefix is bute, new one. Single bonds between the carbons. That's going to be important because butene is going to be a little different. And we have 1 branch, so it's a meth, 1 carbon, YL, because it's a branch. This is all one word. And then we have to let people know where that branch is. Okay? Didn't need to use any prefixes like di and tri because we didn't have any branches repeating itself. So I just wanted to quickly recap a couple things because these are going to be important for us as we move forward. I also wanted to remind you a little bit about these line diagrams. Now that you're starting to draw, you might want to branch out and try some different structural diagrams. So if you recall, when we look at something like this, it looks like a squiggle, but in fact it's actually giving you a structural diagram for a compound, an organic compound. So let's use this little dot over here, and I just have a bunch of them. Every vertices, so every interaction with the where lines intersect is always thought of as that's where a carbon is. So if you think of these little black dots, this might help with the lines. You see these little black dots, you can see that they are representing the carbons, and the carbons are covalently bonded together. So we have 1, 2, 3, 4, 5. That's our parent chain, 5. And the ends of these lines are carbons as well. Okay, so you're not once you get used to it, these are a really quick way of doing structural diagrams, but they can get tricky. Now, with our parent chain, remember longest parent chain, 5 pent, so it's pentane, but we have 2 of these methyl groups off of it, so we have 2 branches here. So you can use lines for your branches as well. 1, 2, 3, 4, 5. If I count this way, 1, 2, 3, 4, 5. So it doesn't matter which way I count. We're going to have pentene, and we're going to have 2,4-dimethylpentene. Okay? So 2, comma, because it's 2 numbers. 4, hyphen, because I got a letter coming. 2, 4. Di this time, because there's 2 methyl groups. Methyl, pent, because we have 5 in our parent chain, and ane, because there's single bonds. There's single lines. Okay? So just a reminder of what those lines mean and what those intersections of lines are telling you that there's carbons there. Okay. We talked about drawing, which we'll talk more about with Alkenes, so I don't think we have to look about, but I will flash this up for you. You might be asked to name a drawing, or you might be asked to draw a name. And so here you can see using the parent name and kind of reading from the back to the front allows you to identify your parent chain, which is always your first step, and then add groups to different carbons in the parent chain. And if you're doing a complete structural diagram, add your hydrogens as well. Okay, I think we are ready. Boom. On to our second family of hydrocarbons. They're the alkenes, and you'll notice the difference here is the ene, and that means something. If you recall, we had a general formula for alkanes, and it was CN2N plus 2. This one's changed a little bit. It's CnH2n. So if it's an alkene, you've got carbon, let's say N equals 4. So 4 carbons means I have 2 times 4, 8 hydrogens. In alkanes, we'd have to add 2 extra hydrogens. In alkenes, we don't. The reason why is because we talk about something called saturated hydrocarbons compared to unsaturated hydrocarbons. So we have to take a second here to talk about saturated versus unsaturated hydrocarbons. So saturated, if you think about a saturated sponge, it means it's filled with water. An unsaturated sponge still has a little more space, okay? Whereas maybe not so pleasant, a saturated bandage would be saturated with blood as opposed to an unsaturated bandage. So saturated really means filled, and unsaturated means not filled. And when we use this, we use it in the context of filled with hydrogen. So let's take a look at some of these examples up here. These examples might look a little different to you. And if you're saying, well, they look kind of similar, Miss Ryan, but what's this equal sign here? This is not an equal sign. This is actually 2 horizontal lines. It's representing a double covalent bond. And that's what makes alkenes special. These aren't alkanes because they have a double bond. If this was a single line, these would be alkanes, and we know how to name those now. And we're going to practice a whole bunch. But these are actually alkenes because they have a double bond. And where did that double bond come from? And so if I show you right up here where that double bond comes from, if you take just a very simple one here, we could name this, couldn't we, guys? Look, 1, 2, 3. Prefix 3 is prop. But look, there's a double bond, so it's called propene. E and E now, not propane. Look for that double bond. You have to have at least 1 double bond. You might have 2, you might have 3, but you have to have at least 1 double bond. What do we mean by that double bond? Well, let's take propane first. And we are experts now, so if we were going to draw propane, A and E, we would draw 3 carbons, because that's what prop is, and we would draw the single bonds between them, and we would fill them in. We'd saturate them, there's that word, we'd saturate them with hydrogens. And so this carbon's happy because he's got 4 bonds, 1 with a carbon, 3 with hydrogen. This guy's happy, 2 with carbons, 2 with hydrogen. This guy's happy, 3 with hydrogen, 1 with carbon. So these carbons are known as being saturated. All of their bonds are filled with hydrogens. Okay, that's what we mean. That's the context we're using for the word saturated. Well, what I want you guys to show is, remember, if I do a dot diagram here, you'll see that This is a shared pair, this is a shared pair, this is a shared pair, and this is a shared pair. And what's happening is, if I take this hydrogen away, this one right here, and I take this hydrogen away, it frees up an electron here and it frees up an electron here. So let's take them away. And when we take them away, okay, carbon has this electron hanging out here and this electron hanging out here. And what these guys say is, hey, you lost your hydrogen. Hey, you lost your hydrogen. Guess what? We can share this pair. And that's how a double bond is born. It's born when we lose hydrogens. Let's go back to that. Are we saturated anymore? No. These guys could have been filled with hydrogen, but we took the hydrogens away. So they did the next best thing, and they did a double bond. So they're sharing two pairs of electrons now. This is called an unsaturated hydrocarbon because it has a multiple bond. So single bonds are single, but if you have a double bond or even a triple bond, and that's where alkynes are going to come into play. If we take these two guys away, just like we took the other two guys away, it frees up two electrons up here. Boom, boom. And carbon can share three. Remember we said it was funky because it could have multiple bonds between itself? This is an alkyne, Y-N-E. So when you have multiple bonds, so when you have carbon, at least two carbons sharing more than one pair of shared electrons, then we have a unsaturated solution. It's not filled with hydrogens. We released some hydrogens. The carbons were able to compensate, and they're still happy because there's three bonds between them. So when you have less than the max of hydrogens, it's an unsaturated hydrocarbon. It's because it has multiple covalent bonds between carbons, either a double bond or a triple bond. There's some compounds that have a double bond and a triple bond. And we have a saturated solution when those double bonds aren't there. Okay? All right, so when we look here, I hope that's clear. So unsaturated, we've lost some hydrogens, so the carbons create multiple bonds between themselves. We can have a double bond, which is represented by two horizontal lines, or a triple bond. And that double bond is the key to being an alkene. A triple bond is key to being alkynes. And I'm going to show you a couple examples of those, okay? So here, guess what? We're never going to have methene. Meth is one. Carbon by itself can't have a double bond. It has to have at least two carbons because the double bond's going to be between the carbons. So there's no methene. It doesn't exist. Our smallest alkene is ethene. So ethene here, you have your double bond. If you remember Lewis dot diagrams and Vesper, you'll know why the bond angles are drawn like that, because a double and a triple bond act like linear. They give you a linear shape. So here we could have had 6 hydrogens, but we took 2 of them away so we could form this double bond here. So this is now unsaturated because it doesn't have the maximum hydrogens it could hold. It has a multiple bond. We call this, same rules as before, 2 carbons, prefix F, but now it's in a different family. It's E and E. These are IUPAC names. Down here are some common names, some traditional names. We're not going to worry about the traditional names, okay? Just the IUPAC names. Over here, now we have 1, 2, 3. Okay, we have our double bond between these carbons. The trick with double bonds is just like branches. You have to let people know where the double bond is. And where the double bond is going to be indicated by a number. In this case, we could have said, because I could count here, 1, 2, 3, and we count the bond where the carbonate started. So if we count this way, 1, 2, it starts there. So it's on the 2 going to the 3. If we count here, though, it's 1, 2. It's on the 1 going to the 2. Just like our branches, we want to count to give our double bond the smallest number. It takes priority. So when there's no double bonds, the branches take priority. Usually, if you're going to number them in alphabetical order, the one that starts first, if you can, you give it the smallest number. Sometimes you can't. But when you get into alkenes, it's the double bond that's the priority. So you're going to count. Even if you're counting and that's going to give you bigger numbers for your branch, doesn't matter. It's the double bond that takes priority. So you have to count your parent chain to give your double bond the smallest number. So there's no choice. I've got to count here, 1, 2, 3. Now prop for 3, ene, I could put one there, or I could leave one off. It's understood that if there's not a number, it's off of the first carbon. Okay, it's off of the first carbon if there's not a number. Over here, I put the number in, but I could have called it butene because 1, 2, 3, 4, there's no choice. I've got to count it this way to give this guy the smallest number possible. He's starting at the first carbon and he's between the first carbon and the second carbon. So we numbered on the first carbon. Okay, butene. You might say, oh, that seems pretty simple, but alkenes can have branches as well. So we want to be careful with these. Okay, so here we have 1, 2, 3, 4. Bute, double bond, ene. It's off of the second. So here we count either way. It's going to be off of the second carbon. So 2-butene. Here we have 1, 2, 3, 4. So all the rules before still fit. Find your longest continuous chain. That's going to be your parent chain. But the key here is your double bond has to be in the parent chain. Okay, your double bond has to be in the parent chain. And so it can't be in a branch. You can't have a branch with a double bond. It must be in your parent chain. Here we do have a branch as well. So we have a methyl. So you might say, well, if I count this way, methyl's off the second. If I count this way, it's off the third. Who cares? The double bond gets the priority. So it's 1, 2, 3, 4. And here we have, oh, sorry, I did count this carbon. 1, 2, 3, 4, 5. So we have to count this way because the double bond starts on the second carbon. If we count this way, the double bond starts on the third carbon. Okay? Here we have a methyl group right up here. It's on the fourth carbon because this takes priority. So we number it 4 for our methyl, 2 for our double bond. So 4-methyl, 2-pentene. See the hyphens between numbers and letters? Okay, important to remember. I said we wanted to talk a little bit about chemical properties as well. And if we come up here back to that general formula I started with, that's where we get to take a +2 off. Because, right, we got rid of 2. Remember, how did we make that double bond? We made that double bond because we removed 2 hydrogens. By taking 2 hydrogens away, it frees up those valence electrons on the carbons, and therefore they can make a multiple bond. So that's why we get rid of the +2, because we took 2 hydrogens away. So for an alkene, the general formula is CnH2n. Important to remember. What can I tell you about these guys? They have to have at least 1 double bond. They are essentially acting very, very similar to your alkanes. There's a few differences, but they act quite similar to your alkanes. Key here, understanding the difference between saturated and unsaturated. Naming here again, I can't go through all the examples, but I'll go through a couple examples here. This one's interesting, just to remind you that your double bond has to be in the parent chain. So even though I could count this way and get 6, that's not going to work because I need this in the double bond. I need this in the parent chain. So I'm going to count this way, 1, 2, 3, 4, 5, and this becomes a branch. Okay? Hexane won't work because you can't have a double bond in your branch. It has to be in the parent chain. And you can come back and take a look at these examples if you want. Okay? Important to get the counting down, and it's important to realize the double bond gets priority. So we'd count this way because it's off of the second carbon. This is interesting, and this is a little different, and I catch people with this one quite often. These 2 compounds have 2 double bonds, and you can see the double bond here and the double bond there. It says 1,4-pentadiene. The 1 and the 4, I think you guys can recognize that here's our 1 and here's our 4, and that's where the 2 double bonds started. But instead of putting the di in front of the pentene, they actually squeeze it in front of the ene. So instead of just saying pentene, they say pentadiene. So the di is actually in front of the ene, not in front of the parent chain, pent. And that's a little tricky when you look at more than 2. If you had 3 multiple bonds, it would have been pentatriene. Okay, here we've got 2 again. We have 1, 2, 3, 4, 5 in our parent chain. We count this way, it's off of the 1 and it's off of the 4. If we count the other way, it's off the 2 and the 5, so we don't want to do that. So we're going to go with 1. We're going to go with 3. There's a comma between them because they're numbers. Then a hyphen because we have a number and a letter. We're going to go with pent because there's 5 carbons there. But the di goes in front of the E in E. So penta, they put an ADI, a die for 2 of them. So be aware of that. There's lots here. If you want to take a look at these slides a little later, I'll uncover the answers. But you can see here we have a double bond. So we have to count it. You can't count it this way. That's incorrect to count it this way. You'd have to count it with the double bond. Okay? So you're actually going to have a branch here with 3 carbons. You're going to have a propyl branch. Okay? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3. 3 propyl, right, off of the 3rd carbon. 3 propyl. 1 heptene, because there's only 1 bond. Okay? 3 propyl, 1 heptene. You can see your hyphens between numbers and letters. Okay? And there's more there you can practice with. I wanted to keep this under 30, so it looks like I'm going to talk about alkynes, and then I'll do a quick little video on cycloalkenes. So here we are jumping into our next group. And a lot of similarities here. All of the rules we talked about are still true. But now what we're looking at is a Y in E. These are still unsaturated because we're removing H's in order to free up valence electrons to create these multiple bonds. You have to have at least 1 triple bond, okay, triple covalent bond. And if you have at least 1, it's part of the alkyne family. And you get a little bit of a difference in chemical properties because of the triple bond. Look at the general formula. Hopefully this isn't a surprise. The C is still in, but in order to make a triple bond, I have to take away 4 hydrogens. And so, if you remember, with alkanes, it was 2n plus 2. With alkenes, it's 2n, and with alkynes, it's 2n minus 2. Every time we create a new multiple bond, we remove 2 hydrogens. So that's important to remember. Okay? I think we're good. Most of the rules are exactly the same for these unsaturated. Let's try a couple examples. Okay? So here's our easiest one. It has 2. There's 3 bonds, or 1 triple bond. And if you guys are screaming ethene, you're absolutely right. Okay? Down here, it's on our first carbon, so we could say 1 or we can leave it out, but there's 3, so it is propene. Here we have a triple bond and a branch, no big deal, but the triple bond must be in your parent chain. That's what's key. If I count this way, 1, 2, 3, 4, 5, or if I count this way, 1, 2, 3, 4, 5, it doesn't really, well, I guess it does matter because we want it off the 2, right? We count the carbon it starts at. So 1, 2. So it's 2. We have 5, so it's pent. It's a triple bond, so it's yne. So 2 pentyne, but we have this branch here, and it's off of your 4, not your 2. Yeah, once you count your pair chain, you got to stick with it. So it's going to be 4-methyl. Oh, come on. 4-methyl 2-pentyne. Okay, 4-methyl 2-pentyne. We can draw some of these too. I didn't really give you a lot of examples for drawing. Here's actually a mixture of all different types. I'd mentioned this in the first video, so I'll mention it again. You can see that we have sometimes our halogens will work as branches. We're going to talk about this family. It's called the halonides, and we'll talk about them next week. But I don't want you to be confused if you run into them. So here, I would call this guy, he's got 2 carbons, so he's going to be F. He's got a double bond, so he's going to be ethene, right? So, ethene, it's on the 1, so we can put the 1 in there if we want, but we don't have to, but you could. So that takes care of the hydrocarbon, but it's got these 2 branches, and bromine gets shortened to bromo, and it's on the first and second. So this would be 1, 2, hyphen, di, because there's 2 of them, bromo, one ethy. Okay, so just don't panic if you see BRs as branches or CLs as branches. They work the same way, named the same way. CLs are chloros. They can be dichloro, trichloro. BRs, bromos. Okay, so some to check there. I guess for good measure, to do one last one, we could take a quick look at drawing something. So let's maybe. Hi everyone, I just paused for a second to make up an example, and I think here's kind of got everything I wanted to review with you before I finish this video. So we are going to draw the structural diagram for this compound. You can see there's hyphens between numbers and letters. There's commas between numbers and numbers. There's a prefix there for dimethyl, so there's two branches of methyls. And you also see there's an E in E. So if I was going to dissect this, I suppose, the first thing I look at is this E and E right here. Okay, so I know there's a double bond. If I keep looking, though, there are two double bonds, right? So you want to start dissecting. And also, I've got a prefix here, and my prefix is "a." Okay, so that tells us a lot, and I kind of work from the back and move forward. So I need to get my parent chain. So I have one, come on, oh, come on, when you're trying to race, that's what happens. 3, 4, 5, 6, 7, 8. Get your parent chain. The two numbers in front of the octadiene refers to where the double bonds are. I always count from left to right when I'm writing, so it's between the 2 and the 3, and it's between the 4 and the 5. So put those double bonds in. Then I can move on to my branches. I have 2 methyl branches. They're on the 2 and the 4. You can put them at the top, or you can put them at the bottom. It doesn't really matter. Okay? Or you can spread them like that. But they both could go on the top, they both could go on the bottom. That's your choice, because it can rotate around that bond easily. And we have one more branch, and that's going to be an ethyl branch, and it's on the 5. So your ethyl branch. And ethyl, remember, is 2 carbons. So you can draw it like this, or you could say C2H5. That's another way that people draw it, right? C2H5. That could be an ethyl branch. And you would put in your hydrogens. With this guy, be careful. If you're putting your hydrogens in, this carbon has room for 4 bonds, so he's got room for 3 hydrogens. This, look carefully, he's already got 4 bonds, no more hydrogens. This guy's got 3 bonds, so he can take another hydrogen. This guy has 4 bonds, this guy has 4 bonds, this guy only has 2, so he can take 2 hydrogens. This guy has 2, he can take 2 hydrogens. And this terminal carbon has room for 3 hydrogens. So hopefully that helps. I'm going to sign off. So that was alkenes and alkynes with double bonds or triple bonds, essentially named the same way. Our third video will be on cyclohydrocarbons and aromatics, and our last video will be on isomers for this week. Thanks very much.